based on the same picture, all we have to do is project each point on the arc to the x-axis, just as we projected each point to the y-axis, and we get a series of points that are the values of what we call the cosine function. Now, this is the sine function. This is the cosine function. Co means complement. This is the complement to the sine function. You don't need to know what the ramifications of that are, but that's where the co comes from, complement of. And you're familiar with complements from your study of geometry. So, if we did that, then, well, the 0 point projects down, well, it's on the x-axis, so the value is, of course, 1, because our x values go from -1 to 1 if we're on a unit circle. And implicitly, the sine of theta and the cosine, and I've got cosine of x, and I really do want to make that cosine of theta. A lot of times we will talk about cosine of x, but right now, since we're talking about x coordinates of the point on the graph, that would be a little bit, tend to be a little bit confusing. Okay, so the cosine of theta function, but again, the complement sine function, uses the x values. And the x value here, if we're on the unit circle, and implicitly, as I was about to say, if the sine function is defined on a unit circle, the cosine function will also be defined on a unit circle. The value of the cosine here is 1. So that's going to give us a point here, because the angle is 0 and the value is 1. And then we have decreasing values of the cosine. They decrease down towards 0, and they decrease through the same values through which the sine function increased. So we get a function whose graph looks something like this. And I kind of missed a point there, but that's okay, we get the idea. And then we go to negative values as we continue going around the circle. The x values start to go negative. I did draw the projection lines lightly here. I didn't draw projection lines here, and I don't think these points are spaced particularly accurately, but it should be clear that we get a graph then that ends up down here, and then comes back up to here, and finally up to here. So that would be our graph of the cosine function. It could be constructed just as accurately as the graph of the sine function. Now, the cosine function has one really neat property. And the cosine and the sine function have complementary properties. Okay, the value of the cosine, it turns out, for a given value of theta, is equal to the slope of the sine graph. Okay, so the cosine function is the slope graph of the sine graph. So big deal. If I had a really prominent color, I'd use it if I hadn't already. It is the slope graph of the sine graph. Now, working out just why it is, if you use these coordinates, the graph that you get is the slope graph of the graph you get if you use these coordinates. We'll let that remain as kind of a mystery. We probably aren't going to go that deep, at least at this point. The other thing is, this isn't true unless the angle is measured in radians. Okay? That's one good reason the angle needs to be measured in radians. Don't have a lot of room to write that. But in order for this statement to be true, the angle must be in radians. That is the fundamental reason why radians is the mathematical unit of angle, because these relationships between graphs and slope graphs are fundamental to calculus and all the analysis that builds from calculus. You won't fully appreciate it now, but if you were using something besides radians, you would have a conversion factor, and as you do various calculus operations, those conversion factors would appear in many different powers. It'd be incredibly confusing. So right there is a reason. Now, I haven't proven this, but you could construct a sine graph. You could then construct a slope graph using the same techniques you've used to construct slope graphs of exponential and power functions. And you could investigate those slope graphs, and you could verify that the slope graph would, number one, have this scale, have this shape, and number two, have the same scale as the sine function, provided your angles are measured in radians and y values from -1 to 1.